Some of you may be in the hostel, or some of you are in the library or in the faculty. So make sure you have a good connection, um, so that there'll be no delay or disconnection. So what we will do is that for the lecture, we try to um, make it online. But if there are some complication, maybe we switch to face lah. Okay. But if we have the face to face, meaning that there'll be no recorded session. But what I can do, I can pick the all recorded session that we have with your senior. But for the tutorial, we will have it face to face. The timing given for us will be on every Tuesday, from 4 to 5 and 5 to 6. But for the data science, maybe we need to have one more slot because you have around 70 plus students. So hopefully in one class, I only can um, monitor like for 30 plus student per tutorial. Okay. So how many we have here? 108. Okay, supposed to be 109. Two missing. Okay, so this is KK04803 information retrieval for software engineering, and KD04303 for data science, those who just joined us. Okay, so we will have 14 weeks, and these are the course objective, to strengthen student ability to understand the key issue. The key issue is related to the basic concept. Let me take my pen. Where is my pen? Let me reset. Let me stop the sharing first. I need to share individual screen only. Okay, can you see the screen? Okay. So in all the courses that you have taken, the most important thing is you need to understand the basic concept of the course. So that is the first course objective, for you to understand the basic concept and technique used in information retrieval. So once you know the technique used in information retrieval, then you can apply this one in your FYP or in your project, or in solving any problem related to information retrieval. At the same time, also you will have some practical on how to build a document retrieval system. Okay, so this is a very simple one, in which you can apply the R software to perform some of the topic like sentiment analysis, topic modeling. These are the some of the problem that we address in information retrieval. Okay, and for the course learning outcome, you will learn the basic concept and technique. This is where you use the vector space model. This is a method or a model that we use in order to represent a document, and then by using this model, then we can compute the ranking of the document. And for the first PLO one, most of the assignment will be focusing on this. Okay, and you will have your midterm also covering this, and also quizzes. Okay, so all quizzes will be taken from the Smart version 3. Okay, so you need to take the quiz before the deadline. So each quizzes will have their own deadline. Okay, and the second one is since you have a practical, so you will be able to demonstrate the differences between unsupervised and supervised learning. Those who have taken machine learning, so you know what is unsupervised, like the clustering, and then how do you perform supervised machine learning. This is for the classification. Okay, so this one you will have your practical training lah. And the last one will cover your final exam. So the final exam will cover almost everything, but will focus mainly on the 60% of the last topic that you cover at the end of the semester. So this one is 40%. Okay. So to summarize, this is what you need to achieve. Continuous assessment for the assignment should be in hand 25%. And also for the quizzes, the quizzes is as long as you read through the slide, you will be able to answer the quizzes. Read and understand. Okay. And the lab practical, basically, you just follow up the what has been demonstrated to you during the demo or during the tutorial. You just have to repeat, but there are some questions that you need to fulfill. So you know already how to do it, but there'll be a question. I just modify the question that, and you need to answer or give the result in your solution. Okay, and midterm again. So the midterm normally will be held before your semester break. So it will cover chapter 6, 1 to 6. Okay, and your final exam will cover almost everything, but will not focus on what already has been questioned here. So, for example, in your midterm, I cover chapter 3 to 5 only, 3 chapter only. Then in the final exam, I may ask you lecture 6 up to the end. Okay. So those who have taken my classes before, so you know what to expect from this class. Okay, all the assignment, all the quizzes, all the midterms, and all the practical must be turned in on time. Sometimes, if I'm in a good mood, I will postpone the due date, but try to uh, complete everything on time. Okay, the textbook that we'll be using will be this one, but in most cases, you can find them in the internet. Okay. Most of the problem that we are addressing here, they all can be found from other sources like from the internet, from the YouTube. Um, but the problem they are addressing will be a bit different, lah, but they are in the same domain, in the same topic. If you have any question, you can uh, ask me. You don't have to wait until the end of the session. Okay. In case if you miss the class, then you will not be able to scan the QR code. So for every time you miss the class, you need to provide a show cause letter. This is just for formality for my record only. Okay. Of course, you can always try to catch up with the lecture and also the assignment, but the attendance, they are very strict on that one. So if you miss my lecture or any tutorial, then you need to provide a show cause letter. Okay. Okay. About the book present an overall view of research. So mainly what we will be studying in this courses will dealing with research. Okay. Mainly in this course, you will be solving problem. Um, I will not ask you about the definition. I will not ask you about an essay question about what is best, which one is good. So all my question will be based on solving problem. Okay, all involve calculation. Okay, so this means that the main focus for this course is more on the algorithm and the technique used in IR system. So you need to know how to compute which number to refer. Okay. Um, in Last time, this course is very important for the librarian because they have to know how to index the book or the document and then how to retrieve the document. Okay. So so that's it for the brief introduction of the course, and I will proceed with the information retrieval introduction. So this one will give you an overview of the whole course for the remaining 13 weeks. Okay, so what you will be studying, what topic you will be covering, and many more. Okay, any question? If you okay, can you type number 8? Okay. I forgot to mention that the add and drop for every semester we have 3 weeks. So your tutorial will start on the third week of this semester. So the first second week you will not have any tutorial. So the tutorial will start on the third week, meaning that your assessment will start on the third week after the add and drop session. Okay. So if you don't confident that you can carry the course, you can drop the course before the 8th week. Okay. Um, any question? No? So can we proceed? Boleh?
Yes, okay, dokter.
Okay. Okay. So the outline for the introduction will be as follows. So first thing we will look into the term information retrieval, the concept about information retrieval, the history about IR, and then we will look at the problem that we are dealing in IR. and some of the system that dealing with IR, and some of um, the impact of the web on the IR. Okay. Okay. When we talk about IR, before we can achieve to this level, we have to know what are the stages involved in IR. So the first thing that we need to know is how do we represent the document? How do we store them? And then how do we organize them? And lastly, how do we access them? For example, we have text, we have images, we have numbers and everything. But in the computer system, they only know about binary. Okay. So due to this fact that you have studied data structure, you have studied database, you have studied statistics, and these courses will help you in understanding how do we store the data and then how do we retrieve them. Okay, so we will look into the representation, and also we will look into how do we rank the document and then how do we access them. Okay. At the at the early goal of IR, we are looking at this. Indexing given all this document we have, and then we try to take all this document based on the index that we have. So the index file consists of all the keywords. So this is the main issue last time. They are looking into the keyword and then how they use the hash file here or hash table here in order to map to the document. So based on the keyword here, they can find the document. So you have studied linked list, kan? You also have studied array of linked lists in your data structure. So you should be able to conceptualize the complex of difficulty when we try to look at here, when we try to implement this. Okay, so we have the file, we have the array of linked lists, and then we also have another one, array to linked list. Okay, so this was last time, but nowadays we are looking into how do we do research in IR that includes modeling, topic modeling. How do we search for certain information? How do we classify the document? And then how do we design the user interface so that it is useful for different domain? And then how do we visualize the data? And lastly, how do we filter the document based on the language that we have? So these were the early goals of IR. Okay. In the 50s, these people initiated research in IR. So like if you found this name in your paper that you are looking for your FYP, Hans Peter Lund, Eugene, Garfield, Philip Bagley. So all these people have coined this term called information retrieval. So we are looking at how do we store them, how do we retrieve the document, how do we get the access in real time, and many more. Okay, so these are the people who are putting effort during the 50s. And then we also have in 1960s, we have retrieval evaluation. How do we evaluate the system that we use to retrieve the document? Okay, so we will study on this one. We will look at the precision, and also we will look at the recall. Okay, so depending on the size of your whole collection and also the size of your retrieved document, you will be able to compute the recall and also precision. Okay, so based on these two, you can plot a graph to show the performance of the retrieval system. So you will study this one in lecture 5. Okay, retrieval performance evaluation. And then in 1963, we have Joseph Becker and Robert Hayes published the first book on IR. So I think this book is a good one for you to have a basic one. So you can Google the author here, and then this is the title of the book. Okay, in information retrieval. I began to start reading this IR using this book. So very simple and easy to understand. If you use this book, this book is what they call it modern information retrieval. So they are full of calculation because this is a compilation of research. If you read this book, this is more like for beginner. So you can look for this book. Okay? And then in the late 60s, they designed this model. They call it TF-IDF, standing for term frequency and inverse document frequency. Okay, term frequency. So this is a model that they use to represent the document. So you will learn this one in lecture 3. Okay, so this is how we use the term weighting scheme in order to represent the document. Okay, so this is the formula. In information retrieval, all the log will be based on log base 2. So we will study this one later on. And then in 1971, uh, Jardine and Risbergen introduced the cluster hypothesis. The cluster hypothesis states that closely associated documents tend to be relevant to the same request, meaning that for the same query, for the same request, documents that belong to the same cluster are considered to be relevant with respect to the query. So for example, like this, the yellow one, they are relevant if your query include forest or approach or distribution. Okay? But if your query has this keyword like density, wood, specimen, test, so all the documents that are relevant with respect to your query will be here. Okay, so this is what we call the cluster hypothesis. So the color will differentiate which cluster belong to certain keyword. Okay, so you will be learning this one also in the unsupervised text clustering. And then later on in 1978, they have the first conference on information retrieval. And then in 1979, um, Van Rietsbergen published another book and they proposed this probabilistic model. Okay, this is a statistical technique used to consider the impact of random event in predicting the potential occurrence of future outcome. So when we apply this one in information retrieval, we are looking at what is the probability of having this word or keyword in this textbook or text document. Okay, so those who have taken machine learning, so this looks familiar. Okay, so what we are looking here is that given the document, what is the probability of having this document as a relevant document? Okay, so machine learning people, you have studied this one before, huh? So we will use this model again in this course, but those who have not taken machine learning, you will study from fresh. Okay. And in 1983, Sultan and McGill. So Sultan is another researcher uh, who are quite popular. They published a book entitled Introduction to Modern Information Retrieval. So they focus more on the vector model. So this is the graphical representation of a vector. So meaning that for each sentence that you have, for example, this is sentence I, okay, and this is the topic. So you want to measure how similar they are. So this is the model that they use to rank the document. They can do the ranking. Okay, so the VSM stand for vector space model. Okay, so they use the cosine function in order to measure the distance between two documents or between the query and the document so they can compute the ranking. So this is what you will be learning more in the lecture 3 through 5. Okay. Okay. Last time it was the libraries who first adopt the IR system. They used the cat catalog searching. If you remember that, I think you never used this one. Last time we used the cat catalog to represent a book. So in that card, they write down the author name, the reference, which block, or which code that you need to follow in order to find the book. Okay. But now we have Google. So Google use subject heading or keyword or the query operator like N O. Okay. And nowadays we also have images. We have sound. So how do we retrieve this kind of more advanced or more complex entity in the web? So these are the more advanced area. Okay, but in this course we are focusing more on the text. So basically we are looking at how did Google perform the searching based on a keyword, and they will give you the list of document display on your screen, and then you find the relevant document. Okay, you thought that the document will be relevant if you click the link. Okay, but if you find that the document are not relevant, then you can change your keyword. So that is what we call query reformulation. You reformulate your keyword. Okay. Okay. So when we at this stage we are looking at problem in IR. So in most cases, IR dealing with finding relevant document with respect to your query. Okay. So for example, mm, let's suppose we have this text or this kind of information required by you. The task is, can you find all documents that address the role of federal government in financing the operation of National Railroad Transportation Corporation? So how do you convert this one into query? How do you convert this one into query? Or what keyword should you put when you try to Google in order to find this kind of document? You want to type federal government in financing only, or you want to say you want to include financing operation of the national railroad, or you want to find the keyword role, the role of or you want to have all of this type in, need all of this. Okay, so there are so many choices. So the idea is, if you asked to find this document, how are you going to find the document or the information? Are you going to type one keyword only, or two keyword, or one sentence, or the whole paragraph? Okay, so if I go back to this, so the IR problem is basically when you have the information that you want to find, you perform the query by typing into the Google search, and then the retrieval system will retrieve and rank the document based on the collection that they have. Okay, so if they do not have the uh, right document, so you may have a poor result here. Okay, so if they have many document, so the retrieval system must be able to rank the document, and then they will present or display the result to you. So this is the problem in information retrieval. We are trying to retrieve relevant document, as much as relevant document, and try to reduce the number of not relevant document. Okay, maximizing the performance of your information retrieval system. Okay, okay. Any question? If you okay, can you type okay? I want to see how many type okay. The rest may be sleeping. Not many yang type okay ni lebih kurang 1, 2, 3, 4, 5, 6, 7, 70 saja ni. So 30 sleeping ni. Okay. So any question so far?
Doktor.
Okay.
Okay.
Okay. So let me proceed. Okay. So let me repeat again. So given the information that you need, how do you transform them into query? What keyword that you should be selecting in order to get more relevant document? Okay, so this is the quite subjective. Some people type the whole paragraph, or some people write the whole sentence. Some people just write one keyword. So which one is more effective? So it also depends on your background knowledge, because if you know that um, if you know more about the subject, then you can be able to um, evaluate how relevant are the document written to you. If you have no idea, no knowledge about the subject, then you tend to read everything, although some of the document are not relevant to you. Okay. Okay. So we we will look into how do we rank the document. So based on the degree of relevancy, so we are looking at the distance between, this is your query, and this is the document I. So we are looking at the distance between these two. Okay. So the formula that we will be using will be the cosine function. So the cosine function will measure how small is the gap. So if the query and the document are very similar, so the angle will be very small. Okay? So the key goal of IR is to retrieve all the items that are relevant to user query. Okay, and then try to minimize the number of non-relevant documents. And the notion of relevant is of central importance in IR. How do you define this? Depending on the similarity or depending on the distance or exact matching. Okay. Okay. This is what I mentioned just now. Consider a user who seek information on topic on their interest, and then they will translate them into query. So from the information that you require, how do you transform them into query? And then later on, how do you expand your query in order to get more relevant document? Okay. If you have a poor background or you do not have enough information, so you will spend more time in browsing or navigating the document because you do not know what is the relevant document with respect to your information. Okay, so this is you keep searching. This is the collection of document that we have. So this is pre-crawl. Pre-crawl means there is a crawl program that will crawl all those information from the web. It will be stored in the file server. It also will be indexed. So depending on the keyword that you type in here, keyword 1 up to n, so you will perform the searching. This document will be sent to you. You will keep browsing, and then based on the document that given to you, you will keep browsing here also. Okay. Okay. Some people ask, what is the difference between information retrieval and data retrieval? So if we look at the information retrieval problem, we are dealing with the degree of relevancy. Okay. But for the data retrieval, we are looking at the exact matching. So all of you have taken the database, kan? So you have the what you call it, SQL. So you using the structured query language, you use the select um, this from what table where the condition is this. Okay, so that is exact matching. Okay, so that is from your relational database. Okay, you deal with well structured. Okay, compared to information retrieval, we are looking at unstructured data. There is no basic structure. Okay, so for that one, we are looking at the degree of relevancy. Okay. 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 When we look at the big picture, so this is the big picture of the IR. You will be learning the concept at each stage. So this is you. Okay. You perform the query from the text field like Google, and then your query will be tokenized and will be parsed, meaning that they will try to pre-process your query. They will shorten or they will expand or they will find the synonym for your query. Okay, so when it comes to the system query, they will try to get all the document that store here. Okay, and of course they will be indexed here. So each document will have index. So for those document, that has close similarity to the query, they will be transferred here. Okay, so they will be ranked here. So this is what we call retrieval and ranking process. So this is retrieval and ranking process. Over this side, the web will be crawled by the crawler, and then they will get the document and they will index the document. And this is what we call the indexing process. Okay? So our task in this course, we will focus more on this side of the area. So we are looking at the retrieval and ranking process. Basically, we are looking at this, the query expansion. We are looking at this, how do you perform the ranking, and then how do you evaluate the system. Okay, so all of the calculation will be done here. Okay? So that is the big picture of IR system. There is another way here. So this part here is described more detail here. So in which this is your query interface. Okay, you put in the query. Your query will be processed here. Either they are modified or they are expanded into a larger or a shorter form, and then they will retrieve your document here, and then they will perform the ranking, and then you will evaluate the ranking document. So basically we are here. Okay. The main factor that influence the activity in IR research is the web. Why? Because of the web, there are a lot of document that has been put up on the web, and more unstructured data we have. So for that reason, we need to process the document to perform ranking and indexing. Okay. So the first major impact is the crawler. So because the crawler, the function is to get the document and store in the database. Okay. Before you can match with your query, you must have all the document indexed here. So otherwise, you will not get any result. So crawler is performed by the Google. So the Google has a server, a farm of server, where they put all the document together with the index. Notice that on the web, when the crawler crawl a web page, they will follow all the hyperlink until the end. Okay, so that's why they call it crawler. They will crawl a page. If there is a hyperlink, they will crawl that page again until there is no link. Okay, so this is the crawler. The second impact is that because of the large amount of input that we have, so we have to look at the performance and the scalability of the IR system. Okay, can you handle thousands of terabytes? Okay, now 1 terabyte is big. So what if we have thousands of terabytes? Okay, so we have to look at the performance of the server and also the how scalable is your server, how much they can be expanded to cover future requests. Because of so much information available on the web, we also be able to perform some prediction on the data that we have. Okay, so predicting relevant is much harder because we have very large collection. And the fourth one is there'll be more information on the web, but how do you extract information about the price of the book, the phone number of a hotel, um, the price of certain item? So your crawler or your process must be able to extract those information and put in a table. For example, um, if you if you want to find the price of durian for over 10 years, there'll be no single table that can give you the exact or what happened outside. In most cases, all those information are stored in a news or in text structure. So you need to be able to capture the price of the durian from the text, from the news, and then you look at the date, the the date of the web page and belong to who. Then you can seek for other resources. Then you can put them in one table. Okay, so that is very Anis Akila requesting to annotate the share content. Okay. So we have to build more advanced technique in crawling and extracting the data from unstructured data. Okay, and the fifth major impact of the web is that is the web spam. So sometimes you're looking for certain information. So some web page know that some people are interested in that particular item. They just put in the web just to make their number of hit higher. Okay, for example, you're looking for certain game, okay, certain uh, online game, and then you're looking for free online game. So when you type in the query, um, usually you will get not free because they ask you to key in your email first and then your phone number, and then suddenly you have so many pop-up window that appear on your screen. Okay, so that is what we call web spam. Okay, and some of the practical issue is the security. um, how do you perform transaction over the internet, and then the privacy, which item belong to who, and then the copyright and patent. This is more into the intellectual property. And then the last one is scanning optical recognition are more important because there are more and more unstructured data being published on the web. Okay, and the last here also we have the cross language retrieval. For example, um, for our online news we have English and Malay. Okay, so both have the same story, same topic, but different language. So this is what we call cross language retrieval. Okay, so to go back to the big picture again, so the one that we'll be covering is this. All this will be covered. Okay, so today we have covered this one, the first week. Okay, so we will follow this, and we have so many and other things. Okay, so we have the modeling here. The most important part is this one. Okay, so if you have taken the machine learning, then you will have some advantages here. Okay, so but those who have not learned machine learning, you will be able to learn them in this course. Okay, and we will not cover indexing and web crawling. Okay, but if we have time, we will cover that one. But I don't think so because we have practical again, and based on feedback from your senior, they ask to have more practical or more sample or more exercise for you guys. Okay, so all of this will be covered. Okay, any question? No question. If you are okay, can you type number 9? Number 9. Do you have any question regarding the course?
Doktor,
Yes.
yang web crawling tu dia software ke apa?
Ah,
Coding ke?
the crawling too, there is a program. So what happen is you can design the program and you can start the seed point where you want to start crawling. So for example, you start from one landing page, contohnya UMS lah, www.ums.edu.my. So that one will be your landing page. That is your seed page. Okay, so the crawler is a program. So they look at your URL and then they go to that site. What they do is just they scan the page. Okay. Let me show you something here. So let's suppose this is your paging your landing page. Let me share. No internet card or server down. Okay, let's suppose that we have this one your landing page. So what happened that they will can you see this website? Boleh.
Yes, yes.
So let's suppose you write a program and you say you put there your seeding point or where you start crawling from this web page. Okay. So what the crawler will see will be only the text and also the hypertext link like this one. So this one will be linked to another document. So before they proceed to all of this text, they will go to here first. Okay. So they go to here, then uh, again they will have more link here. Okay. So this is like a recursive program in which the crawler will keep crawling and keep reading the text, sending to the server, and then they will store the document there. But in the document, they will be stored as multiple pages, multiple document from a single seed. So the crawler is basically a program that you design. Okay. Boleh? you can also Google sample of program for the crawler. So basically the crawler is just um, scanning through the web page and then sending back what each character that they scan through the document. So kira robot lah tuh. So that's why whenever you requesting too much information from one page, they ask you, are you a robot or not? They, they don't want to have a crawler to crawl their web page. Some web page are protected by a password, so you need to be logged in order for you to browse into the intranet that they have. But like open web page, they will be easily crawl. Okay, that's answer your question.
Yes, betul.
Siapa tadi tuh? Siapa nama?
Izudin.
Okay, good question. Any more question? Is this slide available on Smart version 3? Coming soon. Yeah, so all the slides will be available, and also the recorded session of this will be available. Except the tutorial. Tutorial we will have face to face, so no recording. But the for all the assignment that are posted to you, uh, we will discuss the solution, and then I will also share the solution on the web on the Smart Tree for your revision. So based on previous experience, the calculation is not too complex but tedious. So you need to have a lot of practice in order to know what exactly to be done for every step, because there are so many formula. But in the exam, you all will be provided with all the formula, but you need to know what does the formula means. So you need to be able to apply the formula and perform the calculation. So by only doing it many times, then you will be ready to take the exam. So if you do not understand or you have no idea what does the formula means, you cannot do the midterm or the final exam. Very difficult for you to pass the midterm. Okay, and also for you to pass the course, you must be able to get, okay, for your continuous assignment or continuous assessment, you need to get 60%, kan? Your maximum marks. So you need to get at least 50%. So 50%, 30 out of 60. And then for your final exam, that comprises 40% of your final grade. So you need to get at least 50%. So 50 from your continuous assessment and 50% from your final exam. Okay. So if you fail either one of them, that means walaupun your marks is above 50, you fail too, because you did not manage to get at least 50% from both sides. Okay. For example, you get your continuous assessment marks 60, marka penuh, but your final exam you get 10 out of 40%. So your total marks is 70%, 70%, but you fail because you did not manage to get the minimum marks for continuous and also the final exam. 50%, 50%, which is 30% and 20%. So that is the requirement. Okay. Any other question? Siapa lagi yang belum sign in? So if you are able to sign in, that's fine. If not, then you have to stay back and let me know. Yeah. Okay. So that's all for the first week. See you again on next week on Monday, same time. There'll be no tutorial for the first 2 weeks, and the third week we will have our tutorial. Okay. Thank you.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Belum scan, you can stay lah.
Thank you, Doctor.
Okay.
Thank
Bye.
you, Doctor.
Welcome.